Okay, guys. So let me see if my pencil, there we go. If I wanted to solve two equations at the same time before a systems of equations, I would have to say y equals negative 4x minus 5 and y equals x. So if y equals x, I could just plug x in for this y and say x equals negative 4x minus 5 and say, okay, I'm going to add 4x over here and add 4x over here and say 5x equals negative 5 and divide by 5 and say x equals negative 1. And then I have to plug in the negative 1 right there. And if x and y are the same thing, then x is negative 1 and y is negative 1. So that's negative 1 comma negative 1. Or I can just look on the graph and look where they intersect. They intersect right there at negative 1, negative 1. So an easy way to graph, or an easy way to solve these, is if you can graph them both. Look where they run into each other. That's the one point that is on both equations. One line is all the answers for one line, and one line is all the answers for another equation. So the one spot right there at negative 1, where they hit is the one spot that they both agree on. Okay, so these will be pretty easy then. The answer is just negative 1 comma negative 1. Where the x goes first. Are you sure? Yes, I'm sure. Now, I don't have to do basically any work for these, so solving them graphically is sweet. New problem. This one is just what? 0 comma negative 2. Submit answer. Okay, I'm supposed to write parentheses. Okay, whatever. Parentheses 0 comma negative 2. Yes. Oh, I just looked at the graph wrong. Negative 3. Okay, my blind old eyes told me I was looking down at negative 2. Okay, there, I got one wrong. Okay, so we're going to go on to the next problem, but you guys get it. Just wherever they run into each other is the one spot that solves both equations. Okay, we're going to go to a little harder, level 1, where now you actually have to graph some of these. Okay, so instead of the graph just given 1 half x plus 4, so I look at the number term as plus 4, so I start right here at plus 4. The slope is the x term, so up 1 over 2, up 1 over 2. There's my top graph. The bottom graph is I start at positive 7. I look at the number term. That's my y-intercept. And then I look at the x term and say there's a negative 1 in front of the x, so that's down 1. And then I can just put a 1 on the bottom of the fraction, so down 1 over 1. So down 1 over 1, down 1 over 1. You can see, oh, yeah, they run into each other right there at 2. Let's see if I can't write this time. 2 comma 5. So 2 for the x, 5 for the y, and I didn't have to do any math really. I just graphed them, and that's pretty sweet. So instead of all the substitution we had to do before, I guess had you guys do it the hard way before, now we don't have to do that. Okay, so let's do one more. Look at the top equation. I look at the number, the constant term, it's negative 1, so I put a negative 1 down there. It goes down 1 over 3. Boom, there's that one. The top one starts at positive 7. In front of the x is a positive 1. I'll make it a fraction, so that's positive 1 over 1. So up 1 over 1. Oh, it connects way over there to the left, so negative 6 comma 1. Submit answer. Cool. All right, last problem. Come on, don't mess it up. All right, last problem. We're going to go to this level 2. What's the difference between level 1 and level 2? Well, we might have to rearrange some stuff. So the first equation is great. It's in that y equals x term and a y term that we want. We really want it. It's called y equals mx plus b, where we get y equals, we get an x term, and we get a number. When we see that, we can graph it right away. The first one is in that. Y equals, we get the plus 6, okay? And we also get the, I don't know what just happened. I'm going to there we go, plus 6. And we also get the negative 1 in front of the x, so down 1 over 1. There's my first line. But my second problem, I'll do it over here, is 5x minus 2y equals 16. This is standard form. We talked about that last week. And we practiced rearranging them into graphing form, so let's do that. This is positive 5x. If I want to throw the x over to the other side, I have to make it negative. So anytime something changes over and I want to rearrange, I just switch the sign. So negative 5x plus 16. But in our form, the y has to be by itself. So now we're going to divide everything by negative 2, negative 2, negative 2. And we get y equals 5 halves x minus 8, because positive 16 divided by negative 2. So now I can click minus 8, And I can click up 5, 1, 2, 3, 4, 5 over 2. And we can see they cross right there. And that is 4, 2. So I had to do a little bit of work, but still not as much as we had to do before. 4, comma 2. All right, there we go. Let's see if I can do another one. New problem. And I got, the first one's easy to graph. Starts at 4, goes down 1, and then over 1. Anytime there's just, so y equals negative x plus 4. There's like an imaginary negative 1 right there. If negative 1 is my slope, usually I'll put a 1 on the bottom just to let myself know down 1, over 1. Down 1, over 1. Okay. Next one is 3x minus y equals 8. I'm going to throw the 3x on the other side to try to get the right form. And we get negative y equals negative 3x plus 8. I need positive y in the form I'm shooting for. So I'm just going to go and switch the signs of everything. So instead of negative y, I get positive y. Instead of negative 3x, I get positive 3x. Instead of plus 8, I get negative 8. And there's my equation. I start at negative 8, and I go up 3. And I always try to make this a fraction. Up 3 over 1. There's my line, and the intersection point is 3, comma 1. 3 for the x, positive 1 for the y. Submit the answer, and I'm done. All right, those are your problems today. Good.